Hello and welcome to Lesson 1, Communications with Space and Atmospheric Absorption. So in this lesson we're going to cover atmospheric absorption and how atmospheric absorption impacts on the space industry. So the problem we have in the space industry is that we're on Earth and our satellites are in space, so we have to get a signal between the two, which means passing through the atmosphere. And this atmosphere is going to attenuate our signal, it's going to reduce its strength. So the absorption of the atmosphere of different bits of the electromagnetic spectrum actually dictates what part of the spectrum that we can use. So we're going to have a look at a graphic kindly done by NASA, and this shows you how the attenuation varies across the electromagnetic spectrum. So this covers the whole spectrum going from gamma to radio. And it tells you the atmospheric capacity, so it tells you how much of it is absorbed in this case. So if you're looking at both ends of the spectrum, you can see this is very high, so there's 100% absorption. It's not really going to be very useful for sending signals, because you send a signal from the Earth, it will be absorbed by the atmosphere, it will never reach the satellite. But there's bits in the middle that might be of use to us. So we're going to start over on the left-hand side and look at the gamma rays. So gamma rays, X-rays, ultraviolet, 100% blocked. You'll know, if you have anything to do with astronomy at all, that all the images that we get in these wavelengths are to do with images taken from satellites. So you just don't try and do any observations on Earth, because it's impossible, because all the information is absorbed by the atmosphere. You get this nice dip, this drop off at our visible spectrum, and you can see that through the visible light, our rainbow of colours, that we've got quite good opacity, so we get quite a lot of it through the atmosphere, which makes sense because we can see the sun. We then have a section where it comes up and down, up and down, up and down, and this heads into the infrared. So some infrared is great on Earth. In my previous days as an astrophysicist, I went out to places like Ukirt in Hawaii and telescopes in Australia and Chile, where I observed in the infrared. I also used infrared images from satellites, because these were the ones that had just clocked over in the wavelength to the section where there was 100% opacity and you couldn't get that information. So infrared could potentially be used for the space industry, but really it's quite narrow at the bands, and there's other issues with the frequencies at that stage that means it's not actually the top choice. What we have got though is this massive gap on radio waves, which are observable from Earth. 0% opacity. This is the obvious choice for our communications with space. They're also a suitable wavelength, which allows us to encode information in there, which makes them very, very attractive. And indeed, this is where we work, in the radio and in the microwave spectrums. So in this lesson we've learned that the space industry mainly uses radio frequency and microwave frequencies. There is no atmospheric absorption of these frequencies, which is why it's really of interest to us. So the next video is going to be lesson 2, which is looking at radio frequency uses in the space industry. See you there.